Hey guys, today we are going to be completing Unit 2, Lesson 6. This is our last lesson of this current unit. And if you print it out, it is 3 pages. The third page is this reference page right here that I've included for you. Um, it does have a list of all of our properties of equality. Some of these are from Math 1, and some we have rediscussed this year, as well as properties of congruence, and then definitions of the different congruent definitions of congruence that we have learned about. It also includes a postulate and some theorems. And there are actually 4 new theorems on here, which we haven't discussed, but if you think about them, they make sense. A right angle is 90 degrees. The definition of complementary is 90 degrees. So a right angle means that something is complementary. So that's our complement theorem. Our supplement theorem, we've learned that a linear pair equals 180 degrees. We've also learned that supplementary angles equal 180 degrees. So these will equal the same measure. Congruent complements theorem. If A is complementary to B, meaning together they're 90 degrees, and C is also complementary to B, so together they're 90 degrees, then angle A must be congruent to angle C. And then we have the same theorem here, except instead of them being 90 degrees, they're 180 degrees. So these are 4 new theorems that we're just going to add to our bucket. These 2 come from the angle addition postulate as well, and they are just mixed with complementary or supplementary, okay? Because they're talking about specific 90-degree angles or 120-degree angles or sums of angles, okay? So let's take a look at what I put together for you here. And this is proofs. This is something that you've never seen before, okay? So a 2-column proof. So let's talk about what it is. It is 2 columns. On the left, we have our statements. On the right, we have our reasons. Our reasons are always going to be either our theorems, our postulates, or our definitions, okay? On the left, we have our mathematical statements that we're making. And these are going to be the steps that we take from what they give us to what we're trying to prove that get us from A to B. Okay, there are support along the way. And for everything that we claim, we have to have a reason for it. Now here is also a list in one place of all the names of everything that we may use, okay? So let's go ahead and jump right into our first example. So I am given the, let me grab some pens here. They tell me that triangle PQR, right here, PQR is a right angle. Okay, that's a right angle. And that is the very first statement that I make. PQR is a right angle. How do I know that? Because that was given to me. They're always going to tell me at least one thing and ask me to prove something else. Okay? Okay, so PQR equals 90 degrees. Well, that is because of the definition of a right angle. Okay? Definition of a right angle. Okay, now we're going to say that PQS and SQR equal PQR. So what does that mean? PQS, this is this angle right here, my red angle, and my, let's use purple, SQR, that's this angle. They are going to equal, if you add them together, the larger angle. Okay, so that is the angle addition postulate. The sum of the two smaller angles equals the larger angle. Now what we're going to do is we're going to transition and say PQS and SQR equal 90 degrees, okay? So you can kind of think of this in two ways. You can think of angle PQR as a right angle, which is 90 degrees. And I've kind of substituted that information here. So you could think of substitution as one way. You could also use the transitive property. If PQS plus SQR equals PQR and PQR equals 90 degrees, then the sum of these angles equals 90 degrees. Okay. But so you could use substitution, but the more formal way to describe this is the transitive property. Okay, and then finally, this angle 1 plus this angle 2 are complementary. And I know that because now of the definition of a complementary angles is 90 degrees. So definition of complementary angles. Okay, so that is my very first proof. And just notice how it uses definitions, postulates, and properties to go from what I know to what I'm trying to prove. Okay, let's take a look at a second example on the next page. And this is a larger one. Okay, so angle 2 is congruent to angle 3. That's the first statement here. And I can say I know that because it is given information. Okay. I can also come down here and say angle 1 and angle 2 form a linear pair. Angle 1 and angle 2 form a linear pair. That's also given to me. So you don't always have to list the given information together or in one line. Okay. Let's go back up a step to 2. So if angle 2 and angle 3 are congruent, their measures. So this M here means measure. The measure of angle 2 equals the measure of angle 3. And that is the definition of congruent. That's what congruent means. Okay. Okay. Now we can jump down and we can say angle 1 and angle 2 are supplementary. Angle 1 and angle 2 are supplementary. How do I know that? Because they are a linear pair. Okay. They are a linear pair. Well, I spelled peer or pair. Okay, so they're a linear pair. Linear pairs equal 180 degrees. And complementary angles also equal 180 degrees. I'm sorry, supplementary. I'm just messing this all up. Supplementary angles also equal 180 degrees, okay? So the measure of angle 1 plus the measure of angle 2 equals 180 degrees. That is the definition of supplementary angles. Okay. All right, the measure of angle 1 plus the measure of angle 3 is also going to equal 180 degrees. So if 2 is congruent to 3, and I can say 1 and 2 equal 180, then 1 and 3 must also equal 180. That again, you could do either substitution with the angle, or you could say that that is another version of the transitive property. Okay. In this case, let's say I'm going to substitute angle 2 in for angle 3. Okay. And finally, I can say that angle 1 and angle 3 are supplementary. Okay. Again, by the definition of supplementary angles. Okay, so that is our second proof. Let's take a look at a third proof. So this one is dealing with two lines that are parallel being cut by a transversal. So notice that this is a lot of back and forth fill in the blank. Okay, so angle 1 is congruent to angle 4. They gave me that information right here, so that's given. Next, the reason they give me is the definition of congruence. Okay, so the last time that I used the definition of congruence, I started discussing angle measures. So let's say the measure of angle 1 equals the measure of angle 4. Remember that M equals measure. Okay. All right. The next fill in the blank is 3, and they told me this is given information. So what else did they give me? Angle 4 and angle 5 form a linear pair. Okay, so I'm filling that in. Alrighty. Angle 4 and angle 5 are supplementary. How do I know that? How do I know that? That is the supplementary. Where did that go? That is the supplements theorem down here at the bottom. Okay? Or supplement theorem. Linear pair and supplementary. They mean the same thing. So the supplement theorem. To shorthand the word theorem, I just use THM. Okay. 5, the definition of supplementary angles is the reason. So what can I say? Definition of supplementary angles. So let's talk about the angle measures of 4 and 5. Ooh, the sun is getting bright. Maybe that'll help us see a little bit better. Okay, so I'm going to say the measure of angle 4 and the measure of angle 5, if they're supplementary, it means that together they equal 180 degrees. Okay, and so the definition of supplementary angles, let's see, where am I? Okay, now by substitution, what can I say? Let's substitute some angles. So we know 1 is congruent to 4. 1 is congruent to 4. And so if 1 is congruent to 4, then that means that the measure of angle 1 and the measure of angle 5 also equal 180 degrees. Okay. So now how can I say that 1 and 5 are supplementary? That is the definition of supplementary angles. Okay, definition of supplementary angles. Excuse me. Let's look at our very last example. This has to do with a triangle. Okay, so side AB is perpendicular to side BC. Remember that sign or symbol in the middle means perpendicular. So that piece of information is given to me. Next, they tell me that angle ABC is a right angle. ABC is a right angle. How do I know that? Well, that is going to be the definition of AB being perpendicular to BC. Perpendicular means that they form a right angle. So definition of perpendicular angles. Okay. Okay, next, they have definition of a right angle here. So what could that mean? Definition of a right angle? Well, that would tell me that the measure of angle ABC, what does it mean to be a right angle? It means that it's 90 degrees. So whenever you see definition out here, you want to take right angle and say, what does that really mean? The measure of the angle is 90 degrees. Okay. Next, they tell me the measure of angle 1 and the measure of angle 3 equals the measure of angle ABC. What theorem do we know that takes two smaller angles and when you add them up, it equals the larger angle? And that is the angle addition postulate. So sometimes filling in the blank is a little easier than coming up with all of it on your own. Okay, so let's take that further and say the measure of angle 1 and the measure of angle 3 is going to equal 90 degrees. Okay, this angle equaled 90, so these together are going to equal 90. It's my transitive property. Okay. All right. 6, they say the definition of complementary angles. So if the measure of angle 1 and the measure of angle 3 add up to 90 degrees, then that also means that angle 1 and angle 3 are complementary. Okay, because that's the definition. We're down to given. What else did they give us? Angle 2 and angle 3 are complementary. So I'm going to add that right here. Angle 2 and angle 3 are complementary. Okay. Alrighty. So now, what have we put together where we can say angle 1 is congruent to angle 2? That is going to be the congruent complements theorem. Okay, the congruent complements theorem. Let me scooch this over a little and move this. Okay, the congruent complements theorem stated, it's in blue, okay? If A is complementary to B and C is complementary to B, then A must equal or be congruent to C. So that's what's happening here, okay? We proved 1 and 3 are complementary. They told me 2 and 3 are complementary. So then 1 must equal 2. All right. So I do want you to notice that in these examples today, we didn't really use vertical angles. We didn't use a lot of our vocabulary, actually. Let's see. We didn't use the vertical angles theorem. We didn't use the symmetric property, alternate exterior, alternate interior, same side interior. We could have used those in some cases, but when they give you fill in the blank for statements and reasons, we kind of have to go along with what they give us. If I was proving things using just my own thoughts for both statements and reasons the whole way through, sometimes there's lots of different ways that you can go about proving something. And that would be especially true for here. Okay. If I wasn't being guided a specific way, I easily could have said, if angle 1 is congruent to angle 4, and 4 and 5 form a linear pair, I could have used vertical angles and then alternate interior angles and then vertical angles again and then linear pair. I could have gone a totally different route. But the reason I had to take the route I did was because some of the statements and some of the reasons were fill in the blank. Okay? All right, we are going to get some practice on this for tonight as well as tomorrow in class. We're going to spend 2 days reviewing and practicing this content. But that is your introduction to 2-column proofs. Okay, until next time, guys.